3.4 Systems in 3 variables. We're going to look at how to solve systems of equations that each equation contains 3 variables, x, y, and z, a, b, and c. Now, when we look at an equation in 2 variables, then you can graph a line, a straight line. That's what an equation in 2 variables describes. However, when you talk about an equation in 3 variables, then each one, instead of being a line like 2 variables, each one of these is actually a plane. Think of a plane as like a piece of paper. That's a plane. So then when you have 3 of them together, you're looking at like 3 pieces of paper, and where the 3 pieces meet or intersect, then that's considered a solution to the system. So as you can see, it is possible that these 3 pieces of paper are parallel to each other, and if they are, then you would say that the system has no solution. If they don't all intersect, then that's another case where it's also no solution. Notice that only 2 out of the 3 intersect at the points. So there are a few cases where you have either one solution or many solutions, and that one solution is where the 3 planes, they will intersect at just one point, so we call that one solution, or the 3 planes will kind of intersect in a line, and that's a case where we say that there are many solutions. So the first thing we're going to do is I'm going to give you a solution, which is a point where the 3 lines or the 3 equations actually are true, and then I'm going to show you how to plug them in and check to see if that is really a solution. So determine if that's a solution to the system. So what we do is we take each of these equations and we're going to go ahead and plug in the values and see whether or not it's true. Let's call this equation 1, 2, and 3. So let's check equation 1. Plug that in for x, that in for y, and that in for z. So 2 minus 1 plus 3, does that equal to 4? That's the question. So as you can see, this equals to 4. So yes, that does equal to 4. So the first equation is fine. It is true. We move on and we take the solution and we plug it into the second equation to check the second equation. 2x minus 2y minus z equals to 3. 2 for x, negative 1 for y, and that for z. Simplify this, we get 4 plus 2 minus 3. Okay, so this equals to 3, and that's true. So the first 2 equations satisfy that solution. So let's check the third equation. Let's do it right here. So we plug 2 in there, and 1 for y, negative 1 for y, and then 3 for z. Does that equal to negative 3? This is the third equation. This becomes negative 8. This becomes 6. All right? And if we simplify this, we do get negative 3. And negative 3 does equal to negative 3. So that's also a check. And because all 3 equations satisfied that solution, we say that 2, comma, negative 1, comma, 3 is a solution to our system of equations in 3 variables. So we know how to check a solution, but can we find the solution? And that's the main purpose of this lesson, is to show you how to find the solution to a system of 3 equations. Now before we start, I do want to warn you that it does take some time to work through a problem, so have patience and kind of walk with me as I show you how to approach these sort of problems. Alright, so we have a system of 3 equations in 3 variables. We want to find the solution. The first thing we have to do is we have to organize ourselves by let's labeling this as your first equation, your second equation, and your third equation. Now, we want to use the elimination method, which means that we want to eliminate one of these variables first. So you get to decide the variable that you want to eliminate, and I'm hoping that you pick the easiest one. So in this case, the easiest one to eliminate is the variable x, okay? So I'm gonna try to eliminate the variable x. So to eliminate the variable x, we pick any two equations and we have to apply some operation to it before it can disappear. So here's what I'm gonna do. I know that if I take the first equation and I subtract that to the second equation, the x would disappear. If I take the first equation, subtract that to the second equation, the variable x would disappear. So I'm going to do that, but before I do that, I'm going to write out what I'm going to do. So subtract equation number 1 to equation number 2. Okay? So here's equation 1. Here's equation 2. And I'm going to subtract. So subtract, put a little minus sign in between, okay, like that. All right, so x, take away x, that's 0, that's gone. Y minus 2y, that leaves us with negative y. Z minus negative z, technically that becomes a plus, so therefore you have plus 2z, because z minus negative z is 2z. 6 minus 2, that's 4. Okay, so look, you eliminated the variable x. Let's call this equation number 4. We're gonna need this later. Now, so that's two processes. We eliminated variable x from a pair of equations. So now we have to pick another pair, and we're going to try to eliminate x again. Earlier we picked 1 and 2. Now we have to pick 1 and 3 or 2 and 3. It is up to you. It is up to you, okay? So what I'm gonna do is I'm going to pick equation 1 and equation 3, and I'm gonna do the same thing. So I'm going to subtract or add. In this case, I'm going to subtract, okay? So subtract equation 1 and equation 3. So here's equation 1, x plus y plus z equals to 6. Here is equation 3. We're going to subtract. Subtract that, x goes away. We subtract this, we get 2y, okay? When we subtract z minus 3z, that becomes minus 2z. And when you subtract this, you get negative 2. 6 minus 8 is negative 2. Call this equation 5. All right? Now, you eliminated x. We're going to focus on the two small equations, and we're going to try to eliminate another variable. So let's go over here, and let's write these two equations side by side. So equation number 4 is minus y plus 2z equals to 4. Equation number 5, 2y minus 2z equals to negative 2. Awesome. Now we need to eliminate another variable from these two equations. As you can see, z is the easiest to eliminate because their coefficients are opposite from each other. So if I were to just add these two equations together, then the z will go away. So let's go ahead and add these. If I do add these, negative y plus 2y, that leaves me with 1y. These will go away, When I add these together, I get 2. So guess what? I have one of the 3 coordinates. Y equals to 2. Once I have found one of the coordinates, I will now take this and plug it into one of these to find Z. And the one you use, it's up to you. I'm going to use this one. Y equals to 2, so replace 2 in there. That becomes 4. Subtract 4 to both sides. That becomes -6 if you subtract 4 to both sides. And if you divide both sides by -2, then Z come out to be 3. Awesome. So we have found 2 out of the 3 coordinates. To find the last coordinates, we take these 2 and we plug it into one of the original equations. Okay, so let's plug it into that one because that one's the easiest. I guess without plugging in, you can kind of tell me or guess what x is going to be. So this is 3, this is 2, well 3 plus 2 is 5, so x has to be 1, so that equals to 6. Alright, so equation 1, x plus y plus z equals to 6. Y is 2, z is 3, so therefore x must be 6. 5, right? 6 take away 5 is 1. I'm sorry, x must be 1. So there you go. You have your answers. Your answer or your solution to this problem is going to be the order triplet 1, 2, and 3. 1, 2, and 3. Let's do a couple more examples. As you can see, this problem took me about, I don't know, I didn't time myself, but I would say 3 to 5 minutes somewhere. All right, so that is systems of equations in 3 variables. Let's take a look at a couple more examples on how we solve them. And remember to take your time. You can watch the video again if you like. Try to follow the steps that I outline so that you can be successful in solving the equations. Alright, so first thing we do is we label these equations. Call that equation 1, 2, and 3. Okay, now we want to eliminate a variable. So we want to eliminate a variable. Okay, and so you decide on the variable you want to eliminate. Now, if you look at equation 1, we know that x is missing. So let's try to get rid of x from a pair of equations. And as you can see, if I add these 2 equations together, then the x will disappear. Okay? So what I'm going to do is I am going to add equation 2 and 3 together so that the x can disappear. So add equation 2 and equation 3. So here's equation 2. Here's equation 3. So there are times that I subtract, there are times that I add, depending on what's given to me. So I'm going to add in this case. And as you can see, the x disappear. I get y plus 2z equals to 6. I'm going to call this my equation 4. Now, I don't need to do any more work because equation 1 had just 2 variables and equation 4 also had just 2 variables. So I didn't have to do any more work to eliminate x again. Basically, I'll eliminate x until I end up with 2 equations with just 2 variables. So now, my next step is to pick another variable to eliminate. And as you can see, say if I want to eliminate y, then I would need to subtract these 2 equations. So let's do that. Let's decide to eliminate y now. subtract the two equations, what happens here is when you subtract these, that goes away. When you subtract this, this happens to also goes away. So we end up with 0 on the left side, and we end up with -4 on the right side. And because we end up with a statement that is false, we say that the system has no solutions, which means that the three lines, the three planes, the three pieces of papers, they're parallel to each other, or perhaps they do intersect, but only 2 out of the 3 intersect instead of all 3 intersect. Okay, so that was a problem that has no solution. Let's take a look at the last problem here regarding system of 3 equations in 3 variables. And as you can see, I'm hoping that's easy for you, but if it's not, feel free to redo it and try to follow the steps of what I did. And I'll kind of repeat as we move from one problem to the next. So when we solve a system of 3 equations, we want to eliminate one of the variables and eventually get a system of 2 equations. Okay, so we decide on what variable we want to get rid of. So let's eliminate x. Okay, label your equation as well. So to eliminate x, what we're gonna do is we need to pick 2 out of these 3 equations. So I'm gonna pick the first 2 equations, okay? And to eliminate x, I need this number to be a -2. I need this number here to be a -2. So I need to multiply the first equation by -2 and add it to the second equation. Okay, so multiply equation 1 by -2 and add it to equation 2. Okay, so I wrote down what I want to do. I'm going to, and maybe you can kind of make a little note. You're multiplying equation 1 by -2 like that. So here is my equation 1. It gets multiplied by -2, so it gets -2x, -2y, -2z equals to -10. And maybe you can even make a note here, the fact that equation 1 got multiplied by -2. I do not want to change equation number 2, so therefore I leave it the way it is. And then I'm going to add them together, because I know that if I add them together, then the x's will go away. So once I add them together, this becomes -3y minus z equals to -1. This is my new equation, so I'm going to call it equation number 4. Okay. I would need to come up with another equation with only 2 variables. So I have to continue this process by combining 2 of the 3 equations together to try to eliminate x again. But I can't use 1 and 2 because I used it already. So I can use 1 and 3 if I want to, the original 1 and 3. Now, as you can see, the original 1 and 3, they work out pretty well, because if I subtract them, then the x would disappear. So that's what I'm going to do. So subtract equation 1 to equation number 3. So here's equation 1. X plus y plus z equals to 5. Equation number 3 is x minus 2y plus 3z equals to 16. And I'm going to subtract them like that. So what do I get? So this goes away. That becomes 3y. That becomes minus 2z. And that becomes -11. Right? So call this equation 5. So now I have 2 equations, and I have two variables to work with, and that's part of my desire to somehow eliminate one variable for each pair and then ended up with just two equations with just two variables. Okay, so now I begin the next step by writing down the two equations, and part of my goal now is to pick another variable to eliminate. So lucky for us, these two are opposite from each other, and if we add them together, then the y will disappear. That's gone. That becomes minus 3z. This becomes minus 12 when we add them together. So when we divide both sides by negative 3, that becomes 4. So we have found one of our answers, which is one of the coordinates, which is 4. We take this and we plug it in either one of these two, and that will allow us to find the other coordinates. So let's plug into equation number 4. Take that and place it in for z. Add 4 to both sides, that becomes 3. So when you divide both sides by negative 3, you get negative 1. We take these two now and we plug it back into the original, one of the original equations. It is up to you whichever one you want to plug it into, but let's plug it into the first one. So here's the first one, x plus y plus z must equal to 5. Z is 4, y is negative 1, and that's x, and it must equal to 5. So if you like to do some math, you can, or you can just kind of guess what your answer is going to be. So when you subtract 3 from both sides, you get x equals to 2. So then your answer for this problem is going to be 2, negative 1, and 4. Okay, and that's solving system of 3 equations in 3 variables.